Welcome back, dear students. The motion in a plane, the part 4, the part 1, 2, 3. We discussed the vectors, types of vectors, addition, subtraction, and multiplication of vectors, resolution of vectors. Then afterwards, parallelogram law of vectors and directional cosines. These are all topics we discussed. And part 3, we discussed projectile motion. So here two-dimensional projectile motion we discussed. Okay, afterwards the part 4 in motion in a plane, part 4, the most important topic. The maximum students confuse in the river boat cases. River boat cases. Okay, so today class will discuss about the river boat cases. Okay, upstream means what? Downstream means what? Okay, so the shortest path and shortest time to reach one bank to another bank. So to start shortest path is how much, and in shortest time, so at what time, okay, minimum time he reaches other bank. So these all topics detailedly will discuss, including numericals also. Okay, let's start the class. Okay, upstream. Upstream means what? So for example, the flow of river. So one direction is there. So detailedly I'm showing on screen. Okay, the flow of water. Okay, so in a river water. Okay, and one boat is there. The boat also moving along the same direction. Okay, the motion of the boat along the water. Okay, so along the motion of the flow of water. Okay, so the direction both are, if same direction is there, so we'll say that is downstream, we'll say. Okay, if the flow of water in one direction is there, okay, but the boat is moving opposite to the flow of water, against the flow of water, so that time this is called upstream. Okay, now you got. Okay, so the difference between the upstream and downstream. Okay, upstream means what? Along the direction of flow of water. Okay, the motion of the boat along the direction of flow of water is called downstream. If opposite to the boat motion, okay, the motion of the boat opposite to the flow of water, so that is called what? Upstream. Now, so here difference you observe. What happens in this upstream and downstream? So we'll discuss detailedly. Here observe here the boat velocity. Okay, boat is moving relative to the water. The boat is moving relative to the water. So we'll say that is VBW. We say VBW. Okay, the motion of the boat with related to the water, with related to the water, so that velocity is called what? VBW. Okay, so here the flow of water, with respect to the ground, so that is called VWG. The flow of water with respect to the ground, so that one will say VWG. Now the boat velocity. Okay, so the velocity of the boat with respect to the ground, the boat velocity with respect to the ground, will say that is VBG. VBG. Okay, so that is equal to the, in downstream, so what happens? Both are in the same direction, the flow of water and boat direction both are in same. So that is why what I am taking, so addition I am taking the boat velocity, okay, with respect to the water, okay, plus, and the water velocity, okay, related to the ground, so both I am adding. Okay, so now time to travel, okay, from A point to B point, so the distance covered is say D. The covered distance is how much? D. So here how much time taken from point A to point B reaching purpose, how much time taken? So time equal to, so you know that distance by velocity. Here distance by velocity, how much velocity? Okay, so VBW plus V Wg. So this is in upstream. Okay, downstream. Okay, in upstream what happens? We'll see. Here in upstream means what? The motion of the boat. Okay, against the water flow. So what happens the time? It is against is coming. The water flow is rightwards and this boat motion is leftwards against. So that is why what I am taking here. So the boat velocity, the related to the ground, is equal to the relative velocity of boat with water minus relative velocity, okay, water with respect to the ground. Okay, so the t2 equal to time. Okay, time equal to what? From B point to A point here. So we can observe here B point to A point. So covered distance, okay, covered time is how much? B to A. So this is upstream against the flow of water, distance by velocity. The terms, don't confuse the terms. So detailedly I given a boat moves relative to water with velocity. Okay, so that is called VBW, boat velocity with relative to the water, boat water. So VBW we can take, and the water is flowing relative to the ground. Water is flowing relative to the ground. So water W, ground G. So that is VWG. Okay, the last one. Velocity of the boat relative to the ground. So here velocity of the boat B. Okay, and ground G. So that is VBG. So in downstream, what we can take? So plus we can take. Okay, VBG equal to VBW plus VWG we can take. Okay, so here in upstream and downstream we observe detailedly. So here, okay, so one person, okay, so he covered A point to B point. So then again B point to A point traveled. So here total time, how much time taken they are asking. So how to find total time? T equal to what we can take total time? T equal to T1 plus T2. Upstream, downstream plus upstream, downstream plus upstream. So how much time taken? Total time. The person travel A point to B point, then return journey, okay, come back from B point to A point. So the time, total time T equal to what? T1 plus T2. Here T1 is what? D by VBG, water, plus, okay, so water relative velocity of water with respect to the ground, plus, okay, so next upstream, downstream time plus upstream time D by upstream time is how much? VBW minus, okay, VWG. Okay, so this is the total time. Okay, so total how much time taken if they ask, so we should add both the times. Okay, so next, sometimes they'll ask the ratio of downstream to upstream times taken. Okay, so here ratio means how to find. So I am taking T1 divided by T2. I am taking T1 divided by T2. So T1 is what? Okay, D by how much is there? VBW plus VWG divided by whole divided by T2. T2 is how much? D by VBW minus VWG. Okay, here D gets cancelled. Why? Because same distance. Okay, so downstream time distance D only, again upstream also distance is same only, D gets cancelled. So the ratio, okay, T1 by T2 equal to T1 by T2 equal to what happened? This is in denominator, again in denominator. So we can shift to numerator. So VBW minus VWG by VBW plus VWG. Okay, so these are the ratios of times taken. So first downstream, then upstream. Okay, so these are the cases, and last case, third case also there. Okay, so what is the third case? Okay, third case, the case C. If we observe the case C, okay, so what is the case C? Okay, case C is what? For example, here the boat engine is switched off. The boat engine is what? Switched off. So then the boat is flowing through river current. So the time, so what will be the relative velocity and what will be the time? So we'll discuss. Okay, if the boat is switched off, okay, if boat engine switched off, okay, so the time, so what happens, we'll see. Here boat engine switched off, so the time, okay, downstream it is going, okay, so with the help of the river current, so that time what we can take, the boat velocity with respect to the water, so we can take this one 0 we can take. So that time what happened, that time, so here v bw, if you take in 0, so what happened, v bg equal to what we can take, v bw only, v wg only. Why? Because since I am writing here VBW, boat velocity with respect to the water is 0. There is no boat velocity. Okay, so just the boat velocity with respect to the water only it is moving. Okay, so with ground only it is moving. So here time equal to what we can take, time t equal to distance by the velocity, how much, VWG we can take. So now, okay, so from one bank to another bank, okay, so to travel purpose, shortest path and shortest distance. Okay, so with equation only, with help of the diagram, so we'll discuss detailedly. Okay, uh, in shortest path, okay, so the boat wants to move from, okay, so one bank to another bank, so what will be the shortest path? Okay, here we can observe on the diagram, so it is very clear. So from point A to point B, so the boat wants to reach from point A to point B, but the river flow is there, the water flow, okay, so VWG, the velocity of water with relative velocity of water with respect to the ground is what, VWG. Okay, so the person should aim certain angle with the ground. Okay, so that is theta I am taking. The theta angle is moving the boat velocity with respect to the water, so VBW, so it is aiming certain angle. Okay, so that time what happened, the person should reach point B, so with the force of water. Okay, with the force of water. So here let us, we know that already we discussed. Okay, so VWG is what, the water velocity with respect to the ground, and BW is what, the boat velocity with respect to the water, and VBG is what, the boat velocity with respect to the ground. So that time what happens here, observe here, the distance, the width of the bank is how much, distance d, the width of the bank is d. Okay, so now what happens here, the total, the resultant of VBG is equal to what, so V, the boat velocity with respect to the water, plus the water velocity with respect to the ground. So from triangle it is very clear. Okay, ABC triangle, so VBG equal to what, under root, okay, so VBW square minus VWG whole square. Okay, here the cos function, if we take from this triangle, cos function cos theta equal to what? Adjacent side by hypotenuse. Okay, adjacent is what? VBG, and hypotenuse is what? VBW. And like that only sine function, sine theta equal to what? Opposite side by hypotenuse. Opposite is what? VWG by hypotenuse is what? VBW. Okay, so here the angle with the ground, the boat is moving. Okay, so the angle with respect to the ground, how much total? 90 degrees plus theta. 90 plus theta. Here 90 plus theta, that equal to 90 plus theta. So from sine function, sine theta equal to VWG by VBW is there. Theta equal to what? Sine inverse of VWG by VBW. Okay, so next time t equal to what? Distance by speed. Okay, distance is what? D I am taking. Okay, and speed is what? VBW cos theta. So why VBW cos theta only? Why not sin theta? Observe here, this VW is resolving into two rectangular components. Okay, the horizontal, so which one is making angle theta? That one I am taking VBW cos theta, and another one along with the ground, that one I am taking VW BW sin theta I am taking. Okay, so here cos theta taken, so d by, so VBW into cos function is what? VBG by VBW. Here VBW cancel, that equal to d by VBG value already, so we know that. So what is the value? Under root VBW square minus VBG square. So this is the shortest path to reach the one bank to another bank in shortest time. Observe here, the boat should rotate at a certain angle theta with the ground. Okay, so here with the normal it is the 90 degrees. Okay, 90 degrees with the ground. So the bank distance one end to another end is how much? Distance is d. Okay, so the boat is moving, so from A point to B point. Okay, the boat is moving A point to B point. So with respect to the water, the boat velocity is how much? VBW bar. Okay, VBW. Here what happening here? Because of the current water, so the water velocity with respect to the ground VWG. So the with the help of the, okay, water flow, what happened that time? The boat is moving to reaching to another point. So the point is say C point. Okay, the point is C point. So actually the boat is moving towards the B, but with, okay, with the flow of water, what happened that time? The boat reached to C point. Okay, now how to calculate this drift? Okay, so this distance, how much additional distance it traveled, so how to measure detailedly we'll discuss in this, okay, topic. Here observe here in the shortest time, so the boat aim from A point, okay, to B point, but okay, with current of water, what happened? The boat is reached to C point. Here it is very clear the time, how much time taken. So time equal to distance by speed. Here distance is how much? Distance is d. Speed is how much? The velocity of boat with respect to the water. Okay, so here VBW, okay, VBG is what? Actually the boat is moving. Okay, so with respect to the ground is what? This direction A to C. So here AC, okay, so AC is how much from this triangle? Okay, the hypotenuse is equal to under root of, okay, here adjacent whole square plus opposite whole square. So VBG is equal to under root VBW square plus VWG square. Here we need this drift, how much drift it traveled. Okay, so displacement is equal to velocity into time. Displacement is equal to velocity into time. X equal speed is like that only, and time is time is how much? Okay, here we taken d by vbw, d by vbw. Okay, so that is the drift finding purpose in shortest time. So this is the main formula. Okay, so next to total distance, s equal to, so we can take d square plus x square. So total how much displacement is there? So under root d square plus x square we can find out. Okay, so next one we can observe in this. Here the boat started from a point, okay, to reach b point. Okay, so what happened here? The boat, okay, because of the water velocity, okay, the flow of water with respect to the ground vwg, so he aimed certain angle theta with the normal. So then also what happened? The flow of water is more than his aim angle. Okay, so whatever he aimed angle. So what happened that time? The boat reached to another point, d point. Okay, boat reached to d point. So here the vbw, the boat velocity with respect to the water, so he is aiming angle theta with the normal is, okay, vbw. So what happened here? This vbw I am resolving into two rectangular components. One is vbw cos theta, another one is vbw sin theta. So but due to, okay, the river current, what happened? The boat reached to d point. So here drift is how much? X drift. Okay, so here what happens here? Time. So time t equal to how much time taken? So distance by, okay, the width of the river is how much? T. So distance by, okay, velocity or speed, distance by speed, vbw cos theta, this horizontal component. Okay, here how much drift is there? X equal to, x equal to, so the flow of water, okay, with respect to the ground vbw, okay, vbw, but against that he aimed certain angle, so that value I am taking vbw sin theta into time. Why? Because displacement is equal to what? Velocity into time. Here why we taken minus? Here the flow of water is vbw, but against that he aimed certain angle, so that is why minus vbw sin theta. Okay, into t value just now we got, so substitute that one, so you'll get d by vbw cos theta. So these are the shortest time, shortest path, and whatever he aimed angle. So but then also drift is there. So this all we discussed. Okay, based on that numericals also now I'll explain. You can observe first question on the screen. Okay, here the question is there: a man can swim in still water at speed of 6 km per hour, okay, and he has to cross the river and reach just opposite point on the other bank. If river is flowing at speed of 3 km per hour, he has to swim in the direction of, he has to swim in the direction of, they are asking. Okay, so how to solve this one? Okay, so listen here, what they given here. Okay, so speed of man is given how much? So how much given? 6 km per hour, 6 km per hour given. Okay, so and the water, okay, so the river is flowing with the speed of, so river water I am taking, okay, so v water velocity I am taking 3 km per hour. Okay, so they are asking, so what angle he should aim? So here just now we discussed the cases. Okay, which case this one? Okay, the person is aiming like this, okay, certain angle theta. So this is the this is the man velocity. So this is the, okay, this is what? The water velocity. Water is flowing with the speed of 3 km per hour. Okay, the man is speed of 6 km per hour. So then, so what angle? So total what angle they are asking? Okay, here with the ground what we discussed, 90 degrees. First we'll find the theta, then afterwards we'll add to 90 degrees. Okay, So here from figure opposite side we are having and hypotenuse also we are having. Okay, so substitute here sine. Which one is suitable function? Sine function is suitable. Okay, sine theta equal to, why? Because opposite side and hypotenuse we are having. Opposite side is what, amma? V W. Okay, so opposite is what? The water velocity, and hypotenuse is what? The man velocity. Okay, so here VBW, how much is there? Okay, so 3 kilometer per hour is there, and the man speed 6 kilometer per hour is there. Okay, so here 3 1 ja, 3 2 ja. Sin theta equal to how much we got? 1 by 2. Sine function, when we'll get 1 by 2? Okay, theta equal to 30 degrees time we'll get. But total angle, so with the ground, so total angle is how much? Therefore 90 plus theta, so that is how much? 90 plus 30 degrees. Okay, 90 degrees plus 30 degrees, total how much? 120 degrees. So which option is correct? So 120 degrees with the river flow. Okay, so next problem you can, okay, check on screen. Observe here, a person can swim in still water at 5 meter per second. He moves in a river of velocity 3 meter per second. First downstream, next the distance upstream, the ratio of times taken. We know that. Okay, so here the time formulas for downstream, upstream, so we discussed already. So here downstream purpose, what am I? Downstream TD I am taking. Okay, so D by distance by the velocity of the boat plus velocity of the, okay, boat plus velocity of the water we are taking. At the same time upstream is what? D by VB plus VW. Okay, so here ratio they are asking, so downstream to upstream ratio they are asking. Okay, so here TD by T up, the ratio also we taken, so already we discussed. Okay, TD by T up. Okay, so what happened? DD gets cancel ratio time, so this VB, okay, sorry, VB minus. Okay, so this VB minus goes to numerator, VB minus VW goes to numerator, divided by VB plus VW. Here values they given. What are the values? Here the boat speed is given. How much given? Boat speed is 5. Okay, so boat speed is given, so 5 meter per second is given. 5 minus, and water speed is given. How much given? So 3 meter per second by 5 plus 3. Okay, here 5 minus 3 2 by 5 plus 3 8. 2 1 ja, 2 4 ja. Therefore ratio, okay, so downstream to upstream ratio how much? 1 by 4, so that is 1 is to 4. Okay, so 1 is to 4 is the ratio. Which option is correct? 4. Okay, third option is correct. Okay, next problem on the screen you can observe, a man can swim in still water at a speed of 6 km per hour, and he has to cross the river and reach just opposite point on other bank. If the river is flowing at a speed of 3 km per hour and the width of the river is 2 km, okay, the time taken to cross the river. So in this, what they are asking, the person is one bank to another bank, he wants to move, so the separation distance of the river, okay, the banks between the distance also given. How much? 2 km per hour given. Okay, so 2 kilometers given. Okay, so next what they given? The speed of, okay, the person is, the swimming speed is how much? 6 km per hour. So next what to do here? Okay, the time they are asking, so time purpose, what is the formula? Already we taken time equal to distance by, okay, under root, so the man velocity okay, or boat velocity. If boat given, boat velocity you have to take by the water velocity. Shortest time purpose we taken already formulas. Okay, so in this distance, okay, so the distance is given 2 kilometers and the swimming man velocity is how much? 6 kilometer per hour, that is 6 square, minus the water velocity 3 kilometer per hour is given, so 3 whole square. T equal to 2 by, okay, 6 square 36 minus 9, okay, so that is 2 by, okay, how much? Under root, okay, how much? 27. So therefore T equal to 2 by under root 25 seconds. Okay, so which option is correct? Here second option is correct. Next one you can check. The velocity of water in a river is 2 km per hour while width is 400 meters. A boat is rowed from a point, rowing always aiming opposite to the, okay, opposite to point it, 8 km per hour of still water velocity. On reaching the opposite bank, drift obtained is. In this problem they are asking drift. In this drift, okay, so we have to find the drift case. We know that. So what is the drift case? X equal to, so drift distance equal to speed into time. So here speed into, okay, into time. So here drift purpose already we found the formula. So what is the formula? D into the bank distance, how much is there, width of the bank, and water velocity to the boat velocity we taken. Okay, so here drift x equal to, here the width is given, how much given, 400 meters given, and the water speed is given 2 km per hour, and the boat speed is given 8 km per hour. So here 2 1 ja, 2 4 ja, 4 1 ja, 4 100 ja. Therefore x equal to, therefore x equal to how much? Drift is how much? 100 meters. Drift is 100 meters. Okay, which option is correct? Fourth option is correct. So next one we can observe. You can observe on the screen next problem. A person swims at 135 degrees to current of river to meet target on reaching opposite point. The ratio of person's velocity to, okay, river velocity. Okay, so we know that, okay, so to reach one point to, okay, so the target, so the person should reach the, aim the certain angle. Okay, the total angle they given, so how much angle given? 135 degrees given. So 135 degrees means this is a 90 degrees, right? 90 degrees. Okay, total 135 degrees. So this angle is how much? Theta value is how much? Okay, so 135 degrees minus 9, okay, minus 90 degrees, how much? 45 degrees, minus 45 degrees. Okay, now, okay, this is the water velocity, okay, this is the boat velocity. Here theta is how much? 45 degrees. We should not take 135 degrees. So with respect to the ground, total angle is given 135 degrees. Okay, so only the theta value 45 degrees we have to take. So from sine function, sine theta equal to what? Opposite by the water velocity by boat velocity. Okay, theta value substitute here, sine 45 degrees is equal to what? VW by VB. Sine 45 value is how much? 1 by root 2. The water velocity to boat velocity. But in the question, ratio of, okay, velocity of the, okay, the person velocity to water velocity they are asking. So reciprocals you take both the sides. Okay, so what happened that time? Root 2. Root 2 equal to what? VB by VW. Okay, so this is the answer. So four options are given. Okay, root 2 is to 1 also you can take. Okay, which option is correct? So here second option is correct, root 2 is to 1.